everyone, it's Mrs. Martello. We're still in section 7-8. I'm on page 405. We're going to look at example 3, and this is solving an equation by factoring completely. So let's remember, how do we solve an equation? So when we solve an equation, remember we're going to use factoring and the zero product property. So according to the zero product property, my first step is that the equation must be equal to 0. The second step is I'm going to factor that expression completely, and then once it's factored completely, then I'm going to solve. And remember, to solve, you set each factor equal to 0 and you solve each factor. So let's take a look. We're going to look at example 3. So in example 3, I have 2x cubed plus 8x squared equals 10x. Okay, we're going to solve this equation. So first, to solve, I need to get this equation equal to 0. It's not equal to 0, so let's subtract 10x from both sides so that I can get that right side equal to 0. We have 2x cubed plus 8x squared minus 10x equals 0. Okay, I'm going on to the second step. Let's factor completely. So I'm going to go through that list of what I should be trying to factor. The first thing I always look for is a GCF, and this does have a GCF. So let's find the GCF. Out of our numbers is 2. Out of our variables is x, because that's the smallest exponent. So let's take out 2x. Remember, we're dividing. We're left with x squared plus dividing 4x and dividing minus 5 equals 0. Okay, so I factored out the GCF, but now I need to focus inside of here. This expression can be factored more. Let's see if I can factor more. Well, it's 3 terms. This is not a perfect square. That means I'm going to unfoil. Let's do our product sum table. So for our product, the first term is x squared. Our second product is the last term, -5. And our sum is the middle term, 4x. And remember, that's outers plus inners. Okay, let's find our combination. X squared has to be x times x. To get a product of -5, I need one negative number. It has to be -1 and +5 to give me a sum of 4. Let's check our outers and our inners. The outers would be 5x. The inners would be -1x, or just -x. And that does give me 4x, so I found it. Remember, this is first and first. This is last and last. We're going to keep the GCF in front. 2x stays here. Times x minus 1 times x plus 5 equals 0. Okay, I'm done factoring. I can't factor anymore. This is unfactorable, this is unfactorable, this is unfactorable, so I'm done factoring. Now I'm ready to solve. I'm going to set each factor equal to 0 and solve. This has 3 factors. This has an x, this has an x, and this has an x. So this one and this one and this one each gets set equal to 0. 2x equals 0, or x minus 1 equals 0, or x plus 5 equals 0. Let's solve each one. Divide both sides by 2. I get x equals 0. That's my first answer. Add 1 to both sides. I get x equals 1. That's my second answer. Subtract 5 from both sides. I get x equals -5. And that's my third answer. So if I wanted to check my work, all I would have to do is take each one of these one at a time and plug them in for the x's in the original equation up here at the top, and it should work out. Let's try it. If I plug in 0, this would be 0, this would be 0, this would be 0. So that one works. Let's plug in 1. If I plug in 1, this would just be 2, this would just be 8, and this would just be 10. So 2 plus 8 is 10. That one works. Let's try -5. I'm going to use my calculator when I plug it in for -5. So I'm going to do 2 times negative 5 to the third power plus 8 times negative 5 to the second power. I get negative 50 on the left. If I plugged in negative 5 over here, 10 times negative 5 would be negative 50. So I know this one works too. All right, so you can definitely check your answer, and it is worth your while to make sure that all of this work that we just did here leads us to a correct answer. Let's do some more together. We're going to look at monitoring progress number 6. Okay, we have w cubed minus 8w squared plus 16w equals 0. Okay, we're going to factor. Let's find the GCF first. That's always the first thing I look for. This has a GCF of w. Let's take it out. We'll have w squared minus 8w plus 16 equals 0. Okay, let's factor this polynomial in the parentheses. I'm done with the w, that's just the GCF. We're looking inside of here. This has 3 terms. Look at the first term, that's a perfect square. 16 is a perfect square. That means this is a perfect square trinomial. Let's factor this and make this a perfect square trinomial. I'm going to keep the w. This is going to factor to w minus 4 squared equals 0. Just want to make sure that you understand where I got this from. The w squared has to be w and w. And to get a positive 16 and a negative 8, I need negative 4 and negative 4. And that's why it's squared, because I need 2 of these. All right, I am done factoring. Now we're ready to solve. Okay, and when we're solving, we're going to set each factor equal to 0 and solve each one. So I'm going to start with w equals 0, or w minus 4 equals 0. Remember, when it's squared, that just means that there's another w minus 4, but I don't need to write that equation twice. I can just do it once here and get one answer. My first answer is 0. Second answer, add 4 to both sides, and I get w equals 4. And that would be my answer to this question. Let's try number 7. Okay, in number 7 here, we have x cubed minus 25x equals 0. Let's first see if there's a GCF, and yes, there is. They both have x's, so I have a GCF of x. Let's take it out. I'd be left with x squared minus 25 equals 0. Let's keep factoring. Inside of here, do you notice this is another special product? X squared is a perfect square, 25 is a perfect square. This is a difference of 2 squares. So we're going to factor it using our difference of 2 squares method. Remember that when you have a difference of 2 squares, it factors to 2 different binomials, one with a sum and one with a difference. And all we have to do is find out what gives us x squared would be x and x. To give us 25 would be 5 and 5. So this is our factored form, x times x plus 5 times x minus 5 equals 0. I'm done factoring. Let's solve it. So we're going to set each factor equal to 0. Our first factor, x equals 0. That doesn't need to be solved. We're already done. Our second factor, x plus 5 equals 0. If I subtract 5 from both sides, I get x equals negative 5. Our third factor, x minus 5 equals 0. I would have to add 5 to both sides, and I get x equals positive 5. And that would be our last answer here. Okay, let's do another one. We're going to look at number 8. C cubed minus 7c squared plus 12c equals 0. Okay, let's start to factor. First, we're going to look to see if there's a GCF, and there is. Again, this has a c squared, c cubed. Our GCF is c. Let's divide it out. I'll be left with c squared minus 7c plus 12 equals 0. Okay, I'm going to look inside of here, and let's see if I can factor this more. Well, this is 3 terms. 12 is not a perfect square, so let's try to unfoil it. We're going to do the product sum table. So our first product is c squared. Our second product is 12, and our sum is negative 7c. Let's see if we can figure it out. Our c squared is c times c. Well, if I want to get 12 as a product but negative 7 as a sum, I need to have negative numbers in here, but the positive product means I need two negatives. So what times what is 12 and adds up to negative 7? It's got to be negative 3 and negative 4. Negative 3 and negative 4 equal 12. Let's check our outers would be negative 4c, and our inners negative 3c. That is negative 7c. So let's factor it. Keep the c in the front, don't lose that GCF, times c minus 3 times c minus 4 equals 0. Okay, let's solve. We're going to say c equals 0. This one is done. Or c minus 3 can equal 0. Add 3 to both sides. We get c equals 3. Or our last factor, c minus 4 equals 0. Add 4 to both sides. You get c equals 4. And those are our answers. Okay, we're going to do one more problem together here, and this is an extra example. It's not in the book, so I'm going to call this extra example 1. Okay, here's our equation. We have 9d plus 9 equals d cubed plus d squared. Okay, let's solve this equation. First thing we should notice is that this is not equal to 0. We have to get it equal to 0 first. In order to get it equal to 0, I always want to think about keeping the highest degree term positive. Remember that first term should always be positive. Since d cubed is the highest degree term out of all of these, and it is positive right now, I want to keep this side where it is. I'm going to keep both of these here. Let's move the 9d over, and we'll move the 9 over by subtracting them. So I'm going to subtract 9d from both sides, and I'm also going to subtract 9 from both sides. Okay, let's write our new equation. This left side would just be 0 equals, put this in standard form, d cubed plus d squared minus 9d minus 9. All right, it's equal to 0. Let's factor. Look, it has 1, 2, 3, 4 terms. We're going to factor by grouping. Let's group the first two. Make this a plus negative, pull that negative in with the second group and group the second two. Okay, we're going to find the GCF of each group. My first group has a GCF of d squared. If I take out d squared, I'm left with d plus, remember d squared divided by d squared is 1. Anything divided by itself is 1. Let's go to the second group. Our GCF in this group has to be a negative 9. Let's take out negative 9. I'll be left with d, and then negative 9 divided by negative 9 is a positive 1. Look at my common group here of d plus 1. So that's going to be my first group, d plus 1, times the GCFs, d squared minus 9. Okay, I want to remember I'm keeping factoring. I'm going to factor completely. So let's see if I can factor more. Well, d plus 1 cannot be factored more, but look at this second expression over here, d squared minus 9. Do you notice that d squared is a perfect square and 9 is a perfect square and there's subtraction? This is a difference of two squares. So I can factor this expression again. I'm going to keep the 0 and I'm going to keep the d plus 1. Let's factor this difference of squares. It would be d plus 3 times d minus 3. Now we're done factoring, and now we can solve. let's set each factor equal to 0. D plus 1 equals 0. Subtract 1 from both sides, I get -1. Or D plus 3 equals 0. Subtract 3 from both sides to get -3. Or D minus 3 can equal 0. Add 3 to both sides to get D equals 3. And those are our 3 answers.